Welcome to The Explainer. Today, we're jumping into the deep end with the world's most popular programming language, Python. We're going to cover its core ideas in just about 5 minutes, giving you the fundamental logic that powers, well, everything from your favorite apps to actual space exploration. Okay, let's dive right in.
You know, this quote right here, it basically spills the beans on Python's biggest secret, the real reason it's taken over the world. Executable pseudocode, that's just a fancy way of saying the code is so clean, so intuitive, that it reads almost like plain English. And that's not just a nice little feature. It's the entire philosophy that makes Python so incredibly powerful and, honestly, pretty easy to learn. And because it's so easy to read, it's become the go-to language for, well, pretty much everyone. This isn't some niche tool you use for one specific job. Nope. It's an absolute powerhouse that runs a huge chunk of the digital world we live in every single day.
And what's so wild is the sheer variety here. I mean, think about it. The same language that's behind the code recommending your next show on Netflix is also used for programming tasks at NASA. The engine behind Google Search, the thing that syncs your files in Dropbox, yep, that's Python, working away behind the scenes.
So what is the secret sauce, right? Why did all these massive companies bet on Python? Well, it really just boils down to a few key advantages that make it a total knockout choice for everyone, from absolute beginners to total pros.
So first, it kicks off with that simplicity we talked about, which means you can build things way faster. Then there's the fact that it's open source, which means it's completely free and it's backed by this huge global community that's always helping out. Its portability is also a game changer. You can write code on a Mac and it'll just run on a Windows machine, no problem. When you put all that together, you get this incredible versatility. It's truly the Swiss Army knife of programming.
And hey, just to prove it doesn't take itself too seriously, here's a fun fact for you. The creator, Guido van Rossum, actually named it after the British comedy troupe Monty Python's Flying Circus. So yeah, a little bit of fun is baked right into its DNA.
All right, let's switch gears and get into the real fundamentals. If you want to understand how any program works, you have to start with the most basic building block of all, the variable. This is how a program remembers stuff.
Seriously, that's all a variable is. It's just a box with a label on it. You can stick some information inside that box, and whenever you need it again, you just call it by its label. So we could make a box, label it user_name, and put the name Alice inside. Simple as that.
But, our boxes need to know what kind of information they're holding. And these are the big ones. You've got integers, which are just whole numbers. You've got strings, which is just a fancy word for text. A list is just what it sounds like, an ordered collection of things. And then you have a Boolean, which is super important. It can only ever be true or false. That's it.
Okay, so we have our information tucked away in these labeled boxes. But who cares, right? Just storing data is kind of boring. We want to actually do stuff with it. And that's where operators come into play.
Think of operators as the action words, the verbs of programming. They're the symbols you already know, like the plus sign for adding things up or the greater than sign for comparing them. They take our variables and values and actually get a job done.
Now we can basically split them into two main groups. On one hand, you have arithmetic operators. You use these for math, and they give you a number back. But on the other hand, you have comparison operators. These are different. They ask a question, and they give you back a Boolean, a true or a false. Like, is 5 greater than 3? The program answers, true. And this simple ability to ask questions, well, that changes everything.
And that brings us to the coolest part. As soon as a program can ask questions and get a simple true or false answer, it can start making decisions all on its own. This, right here, is the absolute heart of programming logic. So how does that actually work? How does a piece of code choose to do one thing and not another? It all comes down to one really simple but really powerful structure.
It uses something called an if-else structure. First, the program checks an if condition. If that condition is true, it runs a piece of code and then it's done. But if it's false, it moves on to the elif, which is just short for else if, and it checks a brand new condition. And if none of those conditions were true, it just falls back to the else block and runs whatever the default action is. It's just a simple chain of questions.
So here's the magic. We can give the program a number, and using this structure, it can figure out what to do. It asks, if the number is greater than 0, then print positive. Else if the number is exactly 0, then print 0. Else, well, if neither of those was true, the number has to be negative, so print negative. See? It's simple, but powerful decision-making.
And just like that, you've pretty much gotten the core logic of all programming. Let's just do a super quick recap of what we just pieced together.
In just the last few minutes, you now get how programs use variables to remember information, how they use operators to do things with that info, and most importantly, how they use conditional logic like if-else to actually make decisions. These three concepts, they're the foundation of pretty much everything.
I mean, really think about that. A recommendation engine is just a massive series of if-else questions. If the user liked this movie, then suggest another one like it. It's not magic. It's just logic. You now understand that core idea. This is the first step. The only question left is, what are you going to build with it?